back to study section 3 on SOS 201, Principles of Soil Science. In the previous study section, we discussed physical properties of soil science, but here we'll be discussing about soil moisture. The importance of water as a factor affecting crop production cannot be overemphasized. Large expanse of dry but fertile land could be brought into productive cultivation if water is supplied through irrigation. On the other hand, lands usually covered by water need some elaborate drainage system to make them productive. Therefore, this study section will consider the behavior of water in the soil, plant-water interaction, that is, water in relation to plant growth, and the measurement procedures of soil water. So at the end of this study section, you should be able to identify the role of water in plant growth. You should be able to divine the forces that act on soil water. Also, you should be able to classify the types of soil water. Fourthly, you should be able to explain how plants absorb both water and nutrients. Lastly, you should be able to describe how to measure soil water content. Let's discuss this learning outcome after the order. Water is one of the most important components in farming. Water is vital to grass because of the several functions it serves in plant growth. So plant cells are largely made up of water, in which plant tissue is made up of 50% to 90% water, depending upon the type of tissue. When plant cells are full of water, the plant is stiff, which is turgid or semi-rigid, because of water pressure in the plant tissue. So this keeps stem upright and leaves expanded to receive sunlight. Photosynthesis uses water as a building block in the manufacture of carbohydrates. Transpiration or evaporation of water from the leaf helps cool the plant down. Plant nutrients are dissolved in soil water and move towards roots through the water. Water is thus important in making nutrients available to plants. Also, water carries materials such as nutrients and carbohydrates throughout the plant. Water stress is caused by a shortage of water in plant tissue, and stress occurs even as moisture levels do not cause wilting. Plants suffering from chronic water stress are small, with small, poorly colored leaves. Old leaves often turn yellow and drop off. Some plants show some specific symptoms of water stress. For example, the leaves of corn plants curl when they need water. Seed germination is very sensitive to water shortage, while seeds efficiently absorb moisture through the seed coat. The emerging seedling is easily injured by dry soil. A number of forces influence the way the water behaves in the soil. The most glaring one is gravitational force, which pulls water down through the soil. Other forces that pulls down soil water are called adhesion and cohesion. Work against gravity to hold water in the soil is called adhesion, and it is the attraction of soil water to soil particles, while cohesion is the attraction of water molecules to other water molecules. The water molecule is like a bar magnet, positive on the one end and negative on the other end, like bar magnets. The opposite ends of water molecules attract. The bond between the hydrogen of one water molecule and the oxygen of another is called hydrogen bond, which accounts for cohesion. So hydrogen bond also accounts for adhesion. Capillarity. This is when soil water exists in the small space in a soil. As the water film around soil particles, the small pores act as capillaries, and a capillary is a very tiny tube in which a liquid can move against the forces of gravity. Consider what happens after a heavy rain. At first, all soil pores are completely filled with water. This is called saturation. So in large pores, some water is too far from the nearest surface to be attracted by the particles to overcome gravity. So the gravitational potential exceeds the metric potential. So the extra water is being called gravitational water. When it drains through the soil profile, usually within 24 to 48 hours in a well-drained soil, so it pulls air into the large soil pores, especially during drainage. As the soil drains, it pulls the air to fill the soil pores. So eventually the drainage ceases. So the soil moisture level at that point is being called field capacity. Also, we have the permanent wilting point. This is defined as the minimal point of soil moisture where the plant requires not to wilder. If moisture decreases to this or any lower point in time, a plant wilts and can no longer recover its turbidity when placed in a saturated atmosphere for 12 hours. Beyond the wilting point, some capillary water remains but is unavailable to plants. So the capillary water may also evaporate, leaving the thin film of adhesion water. So this point is called the hygroscopic coefficient. The point at which the soil is yet dry is called hygroscopic water. I'm urging you to kindly read more about the types of soils in your study materials for thorough explanation. Water retention and movement. Both the total water holding and available water holding capacity are based mainly on soil texture. Sand grains are large, so the internal surface area of a soil high in sand is quite low. Thus, there is little surface to hold water films. In addition, the pores are large enough that much of the volume of each pore is too far from a surface to retain water against gravity. The opposite is true of a clay soils. They have small pores and a large internal surface area. Thus, soils that are high in sand have a low total water holding capacity, while soils that are high in clay have a large water holding capacity. Not all of this water is available to plants. However, in a soil high in clay particles are crowded together tightly, leaving tiny pores. Any one water molecule occupying one of the pore space will be close to a clay surface. Therefore, it is being called tightly bound. There are several important points to note. They include 1. The fine sandy loamy soil holds more water than regular sand loamy soil, which reflects the influence of very fine sand. The finest soil, clay, has the highest total water holding capacity, but note that it holds no more available water than a sandy loamy soil. Medium texture soil has the highest available water holding capacity, but note that the best soil is a slate loamy. How will the water move into the soil? That is the question being placed before you. Firstly, water infiltrates the soil, then it percolates downward through the soil profile. So the distance, direction, and speed of travel are set by gravity, metric forces, and hydraulic conductivity. Directly below the nozzle of a thickening hose in a column of percolating water. So this water is gravitational water moving under the influence of gravity, that is moving in response to gravitational potential, which is being called gravitational flow. Kindly read more in your study materials for more explanation. Absorption of water by plants. Moisture enters plant roots by the process of osmosis, which may be roughly defined as the movement of a liquid through a semi-permeable membrane caused by unequal concentrations on the two sides. So the role of water in nutrient absorption are: 1. It is generally believed that material must be in solution to pass through the plant root membrane. Nutrients in the soil solution should therefore be in a suitable condition for absorption. It must be pointed out, however, that the presence of nutrients in the soil solution does not assure its use by the plant because of the passage of ions and molecules through the plant root membrane. Movement of nutrients in soil moisture. Nutrients dissolved in the soil solution move with it. So when moisture moves by capillarity, nutrients dissolved in the soil solution move with it. So when moisture moves by capillarity to replace that which have been taken up by plants, a supply of nutrients may be moved near the roots. Transpiration. There has been much discussion concerning the value of transpiration to plants. Some cooling of the plant leaves may result from the evaporation of moisture from them, but there is a difference of opinions as to whether the plant is benefited by these effects. Nutrients must be in solution for translocation to different parts of the plant, and since water serves as the dissolving medium, it is of service in the growth processes that aids its roles as food material. Measuring soil water. People who design or use irrigation systems need to be able to measure the amount of water in the soil. They also need sometimes to name the amount of water present. 4 methods are common in measuring soil water. This includes gravimetric measurements, potentiometers, resistance block, and neuron probes. At the basis of all these are gravimetric measurements. I'm urging you to kindly read up all the methods of measuring soil material in your study materials. I hope you've learned 1 or 2 things from this video. Kindly join me for the next study section. Thank you for listening.